Hello, I'm Saurabh, and today I'm trying to show different machine learning programs done in Python, but with the help of Flask as well as Streamlit to show it online in a more presentable form. I have different programs available here. For example, here the number one I'm going to do is dog breed detection as well as vehicle counting as well, video filter, and some other programs as well. Let's start with dog breed classifier. It's a very simple program with the help of TensorFlow and OpenCV, I trained a CNN model. So I try to predict this image that I have uploaded and it detects it as a Pomerian. Trying to go to the next one, and I also have the car counting program. I had expanded the scope a little bit. As we know that there are a lot of parameters that man can tune in these kinds of algorithms. In this particular vehicle detection app, I had used background subtraction as well as contour detection to count the cars. Here it detects as 7 cars, but we can maybe try to change scale factors, and the number of cars detected would probably increase or decrease. When you also change the parameter of minimum neighbors, the number of cars detected also change. So it's very easy with this app to get started on working on parameters as well as algorithms without the need of actually going through the code, which is also, by the way, available on my GitHub. Another program which I used OpenCV as well as TensorFlow to train a CNN model is basically for traffic sign detections. We have 43 different classes of traffic signs, which I used a pre-trained model for detecting images, and I can very easily drag and drop images. I have an example here. Let's say we go with roadworks, and it detects the roadwork with, it shows 100% confidence, but I had put only 2 decimal points. So yeah, that's one example. Since I like studying and understanding algorithms a lot, I have created this app which shows what one can do with different kinds of classifiers, support vector machine, logistic regression, random forest method. You can choose regularization parameters. There are a lot of parameters actually, and you can choose which graphs to plot. And this app easily prints everything for you. You can also go and change different types of, let's say, logistical regression or random forest. It also shows accuracy, confusion matrix, ROC, as well as precision recall. And let's say another one, classify 92%. Finally, random forest with 100 trees and max depth, it is showing that it has 89% accuracy. You can also ask for raw data and it will show it to you besides all the other metrics. So this is something interesting for understanding different algorithms and what changes they make when you tweak one part of or one parameter of algorithm. Now, I have lots of other apps and programs on my GitHub, which shows easy to understand web-based applications, of course, programmed in Python. But here I'm trying to show one particular program which is very interesting and which is very relevant to robotics as well, because this deals in localization, which is the first step for any robotics application. So here, with the help of CV2, importing all the data and reading the image and everything, tuning up some parameters, defining them, and then getting input. And with the help of that, we have a robot, and we are trying to locate its position, but with the help of particle filters. We have initiated it here in this part, and then um, trying to assign weights according to also, of course, noise, so that we can resample the particles and then try to get an accurate location of that robot. So let's run this program so that I can explain it better. So in this particular program, yeah, this is the map where our robot will be. Now, the green is actual position, the red is predicted position with the help of localization that these particles will try to do. Now, as we can see, they are trying to converge at one point, and as we move our position, the green position, it is getting a lock a little bit. It's not exactly accurate, but um, it will get better when we keep tweaking the parameters. So this is just to show how particle filter works. And another program which is also using particle filters, but in a video, is this one. So let's try to run it, where we are also trying to show how the parameters that are involved with the particle filters. I have showed it here clearly. Let's upload a video to get started on this. So in first, we can see that with this 5,000 number of particles and the noise, which is a standard deviation sigma, as well as velocity sigma, it tracks very accurately even with the occlusion for some time at the end. But what if we reduce the number of particles? Will it make it easier? It looks actually faster. What if we increase a little bit velocity? Then it has a little bit trouble. What about position? So these different types of parameters, sometimes what happens is you are doing a program and trying to play with the hyperparameters, but you don't know which direction to go, which steps to take. Should I increase it particles from 5,000 to 5,100 or 100? Let's try to do 100,000 particles. Still tracks, but you don't know that. So this kind of approach helps understand yourself which parameters in what range works or what doesn't. So that's why I think it's very interactive as well as informative.